Equipotential bonding is a critical safety measure around swimming pools, designed to minimize voltage gradients in the pool area. The National Electrical Code, or NEC, Section 680.26 addresses the requirements for equipotential bonding of metallic parts associated with a swimming pool. Specifically, NEC 680.26c outlines the requirements for a bonding grid. A bonding grid is a network of conductive elements designed to establish a common electrical potential in and around the pool. The question at hand is whether wire mesh used in concrete sidewalks can serve as this equipotential bonding grid, particularly extending 3 feet beyond the walls of a steel-paneled in-ground pool. The answer, based on the NEC, is yes, the wire mesh can be used as the equipotential bonding grid provided it meets certain conditions. The most important of these conditions are continuity and proper bonding at all joints. Let's delve into these requirements in more detail. Firstly, continuity is paramount. The wire mesh must be continuous throughout the area designated for the bonding grid. This means that the mesh must form an unbroken electrical pathway. If there are any breaks or discontinuities in the mesh, its effectiveness as a bonding grid is compromised. Secondly, all joints within the wire mesh must be securely bonded together. This ensures that electrical current can flow freely throughout the grid. Acceptable methods for bonding include welding, brazing, or using listed bonding connectors. The key is to create a low-resistance connection that will withstand the corrosive environment typically found around swimming pools. Now let's discuss the specific requirements of NEC 680.26c. This section mandates that the bonding grid extend at least 3 feet horizontally beyond the inside walls of the pool. This area is considered the perimeter surface. The purpose of this requirement is to create an equipotential plane around the pool, minimizing the risk of electric shock to individuals in the vicinity. The bonding grid must be constructed of solid copper conductor, insulated covered or bare, not smaller than 8 AWG, or rigid metal conduit of brass or other corrosion-resistant metal. The grid is also permitted to be constructed of other approved means. When using wire mesh as the bonding grid, it must meet the requirements outlined in NEC 680.26 Code through C5. These requirements address the size and spacing of the mesh, as well as the methods for ensuring continuity and bonding. It's essential to consult the specific edition of the NEC that is in effect in the jurisdiction where the pool is being installed. Electrical codes can vary from location to location, and it's crucial to comply with the local regulations. Let's consider some practical considerations when using wire mesh as a bonding grid. Firstly, it's important to inspect the wire mesh carefully before installation. Look for any signs of corrosion, damage, or discontinuities. Any compromised sections of the mesh should be repaired or replaced. Secondly, ensure that the wire mesh is properly embedded within the concrete. This will protect it from physical damage and corrosion. The mesh should be positioned so that it is in direct contact with the concrete. Thirdly, use only listed bonding connectors that are specifically designed for use in concrete. These connectors will provide a reliable and corrosion-resistant connection between the wire mesh and the other components of the bonding system. In addition to the wire mesh, other metallic parts associated with the pool must also be bonded to the grid. This includes the pool reinforcing steel, the metal walls of the pool, metal fittings, and any metal equipment associated with the pool, such as pumps, filters, and heaters. All of these metallic parts must be connected to the bonding grid with solid copper conductors of the appropriate size. The size of the bonding conductors is determined by NEC Table 250.122, based on the size of the overcurrent protective device in the circuit supplying the equipment. It's also important to bond any metal fences or other metallic structures that are located within 5 feet of the pool. This will further extend the equipotential plane and minimize the risk of electric shock. The bonding connections must be accessible for inspection and testing. This is typically achieved by installing bonding terminals in junction boxes or other accessible locations. These terminals allow for the measurement of the bonding resistance to verify that the bonding system is functioning properly. The bonding resistance should be as low as possible, ideally less than 1 ohm. A high bonding resistance indicates a poor connection, which can compromise the effectiveness of the bonding system. Regular inspection and testing of the bonding system are essential to ensure its continued effectiveness. The bonding resistance should be measured at least once a year, and any deficiencies should be corrected promptly. It's also important to visually inspect the bonding connections for signs of corrosion or damage. In addition to the equipotential bonding requirements, there are other electrical safety requirements that must be met when installing a swimming pool. These include the installation of ground fault circuit interrupters, or GFCIs, on all electrical circuits serving the pool area. GFCIs are designed to detect small ground faults and quickly interrupt the circuit, preventing electric shock. All receptacles within 20 feet of the pool must be GFCI protected. The electrical wiring for the pool must be installed in accordance with NEC Article 680. This article provides detailed requirements for the wiring methods, grounding, and bonding of swimming pools. It's essential to consult this article before beginning any electrical work on a pool. The NEC also requires that all electrical equipment associated with the pool be listed and labeled for use in wet locations. This ensures that the equipment is designed to withstand the corrosive environment around a swimming pool. Only qualified electricians should perform electrical work on swimming pools. Electrical work can be dangerous, and it's essential to have the knowledge and skills necessary to perform the work safely. A qualified electrician will be familiar with the NEC requirements for swimming pools and will be able to ensure that the electrical system is installed properly. It's also important to obtain all necessary permits before beginning any electrical work on a pool. This will ensure that the work is inspected and approved by the local authorities. In summary, wire mesh used in concrete sidewalks can be acceptable as the equipotential bonding grid required in NEC 680.26c, provided that it is continuous, properly bonded at all joints, and meets the other requirements outlined in the NEC. However, it's crucial to consult the specific edition of the NEC that is in effect in the jurisdiction where the pool is being installed, and to ensure that all electrical work is performed by a qualified electrician. Regular inspection and testing of the bonding system are essential to ensure its continued effectiveness. Firstly, ensure the wire mesh is continuous. Secondly, make sure all joints are properly bonded. Thirdly, embed the wire mesh properly in the concrete. Fourthly, use listed bonding connectors. Fifthly, bond all metallic parts associated with the pool. Sixthly, bond metal fences or other structures within 5 feet of the pool. Seventhly, ensure bonding connections are accessible for inspection and testing. Eighthly, measure the bonding resistance regularly. Ninthly, install ground fault circuit interrupters on all electrical circuits serving the pool area. Tenthly, consult NEC Article 680 for detailed requirements.